Hello, Sid! As a side note, I'm eating lunch because it took like an hour and a half to get here. Okay, let us begin. Homework questions?
Number 57.
Was that one of the ones you texted me about?
Mm-hmm.
It was super hard.
Is it really super?
It's just really hard to get, like, to figure it out.
Yeah.
Would you get 57, Sam? You look so hip today.
Thanks.
This is really spicy.
Oh no, I didn't even try this. Or actually, I did. I got a weird answer.
And you got the right answer?
I got a weird answer.
What was your answer?
0.01745329.
Yeah, the answer is 1. So, okay. I'll do that one for you. These are avocado egg rolls. They're super good. They're really spicy today. Have you had these? Oh, I need to do the thingy.
Oh, you found your nuts? Sorry.
Oh, that's okay. This is good, right? They ordered a whiteboard for us. Oh, they're connected. That's weird. Cool. Okay. Don't you miss the days where you had to just learn how to multiply matrices together? I feel really bad because I was a little extreme when I was explaining to them that one of my number one pet peeves about math is when people pronounce the singular matrice. It's a matrix. It's a matrix. There is no such thing as a matrice. And the only reason this bothers me so much is because over the summer I grade pre-calculus projects for the Orange County Department of Education. And they have to like make videos or do a PowerPoint where they narrate, things like that. And there's like hundreds of students that take pre-calculus over the summer because it's the whole Orange County Department of Education. And they all say matrices. And it bothers me so much because I hear it hundreds of times. And so, just like, no! Okay. So, I'm also trying something a little bit different. I got the Kindle version of the book. So, I'm just going to go on over to that. '57. The figure shows a circular arc length S. It looks like an egg, so just forgive me for that. That's the center, S, and this is D, and this is theta, right? And it tells you and a chord of length D, both subtended by a central angle theta. So because they tell you this is a central angle, you know that this is in fact the center of the circle, so that these right here are radii. So these are R. R. So they want us to find D, oh, the limit. We're not even deriving. They want us to find the limit as theta approaches 0 of S over D. Is that right? Okay. In second thought, hindsight, I shouldn't have given you guys this problem. Sorry about that. All right. I didn't realize until I actually did it that it was a little challenging. Okay. Cool. All right. So, does this look familiar? Awesome. It's arc length equals radius times theta. That's important. You need to know that. This color isn't different enough. Okay. So, oh man, with Sid out, Sid hasn't seen Hunt for the Wilder People. So if we finish early, we can't move ahead. Just saying. We better take all the time then. Okay. So, let's take out this triangle and give it a good look-see. Here's theta, here's r, and d. This is not a right triangle. So if we were going to use any of our trigonometric functions, we would need to use the law of sines or the law of cosines. Those suck. I tried it with the law of cosines just for the heck of it. It takes a long time. So let's split this in half because this is an isosceles triangle. So bisecting that angle produces a right angle. So then this is theta over 2. And this is d over 2. So then the sine of theta over 2 equals d over 2 over r, or d over 2r. Does that make sense? Cool. So then d equals the 2r sine of theta over 2. I don't know why I sang that. I've got no reason. Okay, so now we are looking for they were in here earlier looking for the recess box, like several times over. They couldn't find it, and then I noticed the box was up there, and so I was just like, memories from earlier, and that was it. Okay, so I've got sticky sauce. Okay, so now we're looking for the limit as theta approaches 0 of r theta over 2r sine of theta over 2. Did you get this far? Okay. Bye-bye r's. Okay. And this, we're just going to bring out here because it's constant. And we are left with 1/2 times the limit as theta approaches 0 of theta over sine of theta over 2. Does that look familiar? Does it in some way look like this? What's that equal to? Yeah! So these are reciprocals, so you can jump ahead and say that that's equal to 1. But I also graphed it, and you can see that it approaches 1. You want to have another egg roll? Thank you for letting me eat in class. I feel like I shouldn't say that you guys let me do stuff. I'm a teacher. I'm super authoritative. What do you think the first person to eat avocado, what do you think that was like? Think they liked it? Think they tried to bite it and they got the pit and broke their teeth? Maybe. I don't know if I would try to bite an avocado though, like feeling the rind. And they had to learn when it's ripe and when it's not. An unripe avocado is unpleasant. You know what I mean? I wonder if there's a way for me to figure out if Sid is watching. Oh yes, we are. Live now because I can see the egg roll in my hand. Did you graph it?
Yes.
And?
The limit is at 2.
Oh, because it says 1/2.
Yeah.
How do I save that? I don't know. Oh, I'm chewing. Okay, anyway, sorry. Because that's the reciprocal times 1/2 is the reciprocal too. Yeah. If you don't take that out, then you get 1. Good. Cool. Okay. Any other questions?
Yep.
Okay. I'm ready. I did your homework. I'm so proud.
Number 53. Number 53.
Oh. Sorry, I'm looking at my work. I see 51 and then 55. I know I did 53. Oh, maybe that's why I didn't do it again. It's really weird to just see myself chewing from a downward angle, which, as everybody knows, is clearly the most flattering. Right. I didn't redo it because I'd already done it. Okay. Oh! That's the most awkward person I've ever met. How am I so much more awkward than everyone else? I just don't get it. These are so spicy today. Have you guys ever been to BJ's? Is it good? Did you enjoy it, Sam? I enjoyed it there. It's a little extravagant for like just a weekday lunch for myself. But I felt really sorry for myself after doing the Seder. That was a lot of work. Okay. Okay. Oh, phew. Okay. So if this is y, right? Then 2y equals 2a sine x plus 2b cosine x. Following me so far? Okay. And then y prime is equal to a times the cosine of x, and then it would be plus b, but because this is going to be negative sine x, minus b sine x. Y prime, double prime, is equal to the derivative of this, so negative a sine x minus b cosine x. Cool. Sorry, I've got like egg roll grease all over my left hand, so I'm just trying to do it one-handed. Got it. Okay, so want this to be true. So you have a negative a sine x. This is our y double prime. So negative a sine x minus b cosine x plus y prime, which is a cosine x minus b sine x minus 2y. So minus 2a sine x minus 2b cosine x equals sine x. Did you get this far?
Yes.
Awesome. Okay. So let's see what we can just like. So, see, as far as a sine x's go, it looks like we have negative 3 of those. Negative 3a sine x. And then b cosine x, we have minus 3b cosine x. And then plus a cosine x minus b sine x equals sine x. So, how many cosine x's do we have on our left-hand side or right-hand side? Yeah, over here. Exactly. So, whatever this and this are, they add up to 0. And how many sine x's do we have? So, this and this equals 1. And then you just solve. Yeah, I'll just go ahead and finish it up. So a equals 3b. So negative 9b minus b equals 1. B equals negative 1/10. And then let's do this one. 3/10 plus a equals 0. So a equals negative 3/10. Yay! Did I tell you that we're going to have a big whiteboard? I did. I'm very excited about it. I think it's one of the big one, rolly ones.
Oh.
How cool will that be? Cool. I guess I don't need to have this facing down anymore. That would have been very in character if I had had that facing up while you took your quiz. Right? Yes. Okay. I'm sorry. Want to fix it? Okay. Come in. That's okay. Yes.
I'm Amber's mom.
Hi.
Email. Hi.
Amber Fleming.
Amber Fleming. She loves you.
Oh.
Adores you. Oh my goodness.
Thank you.
Is this
Yes.
Both their photos.
Okay.
I'm trying to do photos here.
Oh,
She's leaving,
okay.
the photographer, so I just wanted to
Okay.
make sure we didn't miss anyone. That's
Just
the
for the
only
day. I'll
place.
be back another day. If I
Okay.
did miss somebody, if your friends that you know didn't get their photo, I will be back.
I do have a student who's absent.
Okay.
Oh, well, that's
Okay.
even
So
better.
we have makeup day, so
Okay.
we just didn't want to.
Nice to meet you.
Nice to meet you. Thank you for letting us intrude.
Sure.
Bye.
Amber's in my ancient history class. I fed them. Kids like that. Should I feed you guys? I feel like that's a hint. What do you want?
What do I really want?
Well, not now. It'll probably be Wednesday.
Oh.
It's a little late in the game for today, since it's already in the middle of class.
I mean,
Unless you want this.
no, thank you. I'd be taking away from your lunch anyway. So.
I have a salad. You want it?
Are you sure?
It's pretty spicy, but you can have it.
Thank you.
You're welcome. I caution you against writing with the greasy hand after. And here's a paper towel. Because that's what they gave me for napkins. Good, huh? It's super spicy.
Sort of.
Are you Korean?
Yes.
Okay. So, not Korean spicy.
Yeah.
Okay. I don't know what it is that makes it spicy. Do you recognize whatever spice it is? It burns too much to be wasabi. Wasabi doesn't burn. It's a cool burn.
It's like right here too. I don't feel it right here.
Yeah. I like wasabi. Except I have a tendency to accidentally put it on the top of my sushi. So when I take a bite, it just like pastes itself on the roof of my mouth.
Oh.
That's where your nasal stuff is connected. And I'm just like, ah! Because of course I do, right? Well, but I eat it. Okay. I do that like every time.
First day sushi.
I like sushi. Cool. Okay. So which problem next? 37? What does 37 say? Oh, actually, I can look in my little notebook because I did it. I'm just so proud that I did your homework.
This one took me a while.
Oh. It did? It's a word problem. Okay, so you have 37, which says you have a 10-foot ladder leaning up against a wall. Do we need to know how high the wall is? No. And it says it's sliding away from here at x. Is that right? Okay. And then this is theta. And what does it ask us?
How fast is x changing perspective theta when theta equals 5 degrees?
Okay, so if we're finding how fast x is changing, that's the rate of change, that's going to be the derivative, right? So, let's think about it. Sine of theta equals x over 10. So x equals 10 sine theta. So, that's our derivative. And then that's, yeah, you get it. So, no, that's not our derivative at all. I'm just about to do the derivative. Sorry, I don't know what I was thinking about. Like my mind was focused on something. Gosh, I'm sorry. that I'm so me. Cool. Okay, so d dx of this is going to be 10 cosine theta. Does that make sense? Okay. And since it wants to know specifically when theta is pi over 3, we have 10 times the cosine of pi over 3. Unit circle quiz. Do you remember what the cosine of pi over 3 is? One half. So, how did I get 5 rad 3? I just wrote the answer down. Is that the right answer? Seems like it should be 5.
Yeah, that's a 5.
What's the right answer say? Oh, okay. So, I don't know why I wrote rad 3 there. 5! There we go. I was doing this last night really late. I know. I was really proud of myself that I did it, but I was up until I didn't start doing this till like 11. But I remembered that it was a priority. Okay, so any other questions? 49. And does this thoroughly and adequately solve this? Okay. 49. So it wants us to take the limit What do you think they're doing? They all playing whack-a-mole? They could be. It would make that noise. So as x approaches pi over 4 of 1 minus tangent x over sine x minus cosine x. Right? Okay. Can we plug in pi over 4 here? No, because then we would get rad 2 minus rad 2 over 2 minus rad 2 over 2, and that would be 0 in our denominator, and that means that Jesus came back. Do you get it? Because the 0 in the denominator, end of the world. I thought it was funny. Okay. That's sad. Okay. Woo! Let's try this. Because what we're trying to do is get it to where our denominator is anything other than 0. Wait, I did it 2 different ways. Okay. So far, so good? Yes? Okay. So, yeah. What did I do? Oh, I actually multiplied it out. Okay. Which equals the limit as x approaches pi over 4 of 1 minus tangent squared x over, okay, so sine x, as we're foiling, and then plus sine x tangent x, and then minus cosine x, and then, let's see, minus cosine x tangent x, okay. So, where did I get that from? Sorry, I shouldn't do the homework as late anymore because I'm not following my own steps. So, good times. So if I factor out from here a sine x, it leaves me 1 plus tangent x. Yeah, why am I doing that? I did that before. And then minus. Why would I do that? Oh, I see. I did it 2 completely different ways, and I stopped halfway through right here because this way I wasn't getting anywhere. So the moral of the story is that sometimes you have to try a few things. How does that work? Like when you're verifying identities, because there's not one absolute way to find some of these things. You have to try a bunch of different stuff. Okay. Yes, that way led nowhere. Okay, I'm sorry. You copied down everything I wrote, didn't you? That's okay. I'm just telling you it's okay, but I am sorry. Okay. So, the first thing I'm going to do from the top, is I'm going to write it in terms of sine x, cosine x. And then I'm going to get a common denominator. Does this make sense, or do you want me to show the steps of how I got that? Okay. One is cosine x over cosine x. So cosine x minus sine x over cosine x. Over. Oh, no, I'm not done. I'm sorry. Minus cosine x. Which equals negative 1 times sine x minus cosine x over cosine x times sine x minus cosine x. Feels so good. Imagine I put the limit thing here too. Equals a limit as x approaches pi over 4 of negative 1 over cosine x. Much easier. Which gives you negative 2 over rad 2, which gives you negative rad 2. Make sense? Excellent. Oh, low battery. Plug in my computer. I took off my shoe, I guess. It would not be as awkward if I didn't say as much stuff out loud, right? Would it be less awkward if you just saw me doing weird things with no explanation?
Might be a little bit.
Okay. There's just no fix.
It's okay.
Oh gosh, what is that? Yes. But you have to leave the door open because then Avery and I will be in here by our lonesome, and I have to have the door open for that. Okay. Oh, I just remembered what I was going to do on my lunch break that I didn't do for my next class. That's okay. Because I graded your quizzes. And that's important. How was your weekend?
It's good.
Good.
Yeah.
You saw Hamilton
Yeah.
at the Pantages?
Uh-huh.
How was it? Who was any of the original cast in it?
No.
But probably still pretty good.
Yeah.
Oh my gosh. The only thing though is that they probably swear a bunch in the original. Yeah. I listened to the edited version.
No.
So cool. How long ago did you have to buy tickets?
I don't really know actually.
Okay. Did you buy them?
No, my grandma did.
Oh, that's nice.
Yeah.
I did maintenance on my car. I changed the oil, and I changed my battery, and I changed my cabin filter, and I changed my brakes. It took a long time, and I got really dirty. Hey, Sam. Okay. And feel free to scoot to one side or the other. Excuse me. Okay. Any other homework problems?
Number 31.
31A. You know, I'm not embarrassed that I did the wrong way first because whatevs. You have to try a couple things. Yeah, I'm not ashamed. I'm more speaking to myself. Okay. So, what does 31 say?
Use the quotient rule to differentiate the function tan x minus 1 over
So that's all we need to do?
Yeah.
Okay. So, first step is to take this one, secant x, and multiply that times the derivative of tangent x minus 1. Okay. It looked like you were going to ask a question. Okay. Which is secant squared x, and then minus tangent x minus 1 times the derivative of secant x, which is secant x tangent x. You just start doing some curls. Okay. Oh my gosh, I was so sore after changing my brakes though. Rotors and wheels are heavy. And so are brake lines and calipers and pistons. I didn't know how heavy they were. So I was YouTubing it and I went,
You had your own brakes?
yeah,
Wow.
Thanks. The guy at Costco was super impressed too, and I turned in my old battery. Just walked in holding my battery, and he's like, "Do you want me to take that?" And I was like, "I got it." And then, like it was nothing. He's like, "Wow, you changed your brakes? Did your dad show you?" And I was like, "No, I YouTubed it." I was really, really scared when I got in the car first time after. But it works. It works. Stops smoothly. It's doing what it's supposed to. I'm going to try to change the spark plugs next, but I need to order a really big magnet. Cool. Okay. Over secant squared x. Okay. Excuse me. Which equals secant cubed x minus secant x tangent squared x plus, secant x tangent x over secant x what number is this? 31. Okay. Oh, yeah. Okay. So, factoring out a secant x, we get secant squared x minus tangent squared x plus tangent x over secant x. Yep, it is. I was anticipating the canceling. Hurry. Good call. Now it's secant x. Okay. So, do you remember your Pythagorean identity with tangent squared? Tangent squared x equals, or plus 1 equals secant squared x? Oh, that would have been helpful. Because this is 1.
Had to be something.
Yeah. There it is. Any other homework problems? That was it?
Yeah.
Awesome. And Avery quietly and daintily shook her head. So, moving on to the chain rule. Do you guys know Aretha Franklin? Not like personally, but know who she is?
Yeah.
Have you ever heard this chain song, The Chain of Fools? And they go, chain, 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 chain of fools. You don't know? Okay. Today we're doing the chain rule. I always get that song stuck in my head. Okay. Bad. Oh, hello. I was very close to my face. Okay, you kind of see the board. Now there's a red line on the screen. I don't know what that's for. Oh, picture cuts off there. See my hand disappear. You want to try it? It's pretty similar to every time you've ever looked in a mirror, and there's an end to it. Okay. Chain rule. Excuse me. So, in true math fashion, we are now going to make things more difficult. Yay! So you know how so far we've learned how to differentiate a product, a function, like a product of functions, quotient of functions, even trigonometric functions. What about composite functions? Yay! Super fun! Calculus is the best. Have you guys seen Nacho Libre? Have I talked about him already? I talk about him a lot. Did you tell them that they were the Lord's sheep? Okay. I really like that movie. My internet was out. Did I tell you guys that a few weeks ago? The neighbor got Dish TV or Direct TV or something, and when they came over to install it, they unplugged our cable and then plugged theirs in. So we had no cable or internet or phone for like a week. We just watched Nacho Libre on DVD the whole time. It was actually pretty good. It's a good day. So, week. I meant a week. So then how would we do this? It's not a product. It's not a sum. There is a sum, but there are two major things going on here. Right? We first would need to plug in our x here and simplify that. And then we would need to take the square root of it. So when we're differentiating it, what we now need to do is what the heck class is that? Okay, so now we're going to try to get it using substitution. So we break it down into two distinct functions so we can write it as a composite function. Does this make sense? Okay. So if you want to see the proof, it's in the book. It does take a while. I think it would probably be easier if you just memorized that when we're taking the derivative of composite. Oh my gosh. Who wants to pop their head in that class and see what they're doing over there? They could be beating children for all we know. Why would they do that inside? Do they have PE here?
I think you might have another class that's already going on outside.
The storage closet doesn't look that bad right now. Okay, so to take the derivative of a composite function, you take the derivative of each one and then multiply them together. That's it. So the derivative of this is 1/2 times u to the negative 1/2 using the power rule. And the derivative of this is 2x. Do you want an eraser, Sam? I have erasers if you'd like to use one.
No, it's okay.
Okay. So plugging u back in is x squared plus 1. That x doesn't look like an x. Man, those things were kind of spicy and greasy, and now I have like indigestion. More water. I just remembered the other thing I was going to do over lunch break. Other than actually write my lesson plan for my next class, I was also going to go get the chocolates out of my car. Now melted. It's really hot today, isn't it? Dang it. Okay. Does this make sense? Everybody's okay with this? Okay. The chain rule is called the chain rule because we're allowed to composite the crap out of these functions. You remember earlier when we were doing like f of g of h? So you just have to continue moving down along, multiplying all the derivatives together. So sometimes when you are multiplying the derivatives, you need to use other rules on top of it. Is that me or him? I just thought of something funny. I have to use the bathroom, but I don't want to because I heard that when an adult goes in there now, all the students have to leave.
Really?
That makes me feel really weird about using the bathroom. But what if I forgot to take these off? I'm streaming live. I'm so glad I thought of that beforehand because I probably would have done it. Oh my god. Oh no. Okay. So it does prove the chain rule for you, which is not necessary to being able to do it. And then, let's see. Yeah. Okay. So, but first, let's just do another example. My pink one is wearing out really fast. It makes me sad. It's like all black and smudgy. So, where did my eyes go? Where am I looking? Oh. So we're going to differentiate each one of these. So the only real trick to when you have a simple application of the chain rule like this is identifying what your two functions are. So we have squaring x, and then we are taking the sign of it. Order of operations is key. X squared is in parentheses, so that is what we need to do first. So we have, like, for example, u equals x squared, and then f of u would be sine u. Does that make sense? Okay. So now we just need to take the derivative of u times the derivative of fu. F of u. Stop smiling, Sam. You can listen to my laughter, but you can't smile. Okay. So that's just 2x times cosine of x squared. Could be times cosine of u, but I'm going ahead and subbing x squared back in for you. So then here, it's just flipped. Our u would be sine x, and then our f of u of is u squared. Calculus is fun. Okay. So, taking the derivative of this, we get cosine x, and then times the derivative of u squared is 2u, but u is sine x. which you do not need to recognize as this, but it would be good if you did. I wish I had an actual just like classroom where I could just write all of these identities out. In fact, I'm going to make a note to give you guys a sheet with all of the identities on Wednesday. My knees are so sore from being like on the ground, jacking up the car and all of that stuff. Ow. I guess that's why they wear knee pads, right? Have you seen them do that? I've seen them do that. Didn't think about it because I was pretty much just petrified. And my husband also said, which was very assuaging. Do you know what assuage means? Like relieving, calming my fears. He said, don't let the car fall on you because I'm going to be mad. And I said, you mean if I die? You'll be mad? And he's like, yeah. All right. I didn't die. Yet. It is good. I'm happy about it. Okay. And then, so they have in a blue box for you the power rule combined with the chain rule. But for me personally, I feel like this is kind of unnecessary because you use the power rule to take the derivative, so we've already been doing it. Does that? I'll show you what they mean, or what I mean. So they tell you to differentiate this. So but recognizing that we have a whole other function in here and not just a second variable or a variable, we would need to multiply that times 3x squared because that's the derivative of this inside term, and that's what the chain rule says you have to do. You have to multiply the derivatives together of each function that combined to make a composite function. I almost sounded smart for a second there. Did you hear how like serious I got? And I heard it. It stood out. You must take the composite function and decompose it into two individual functions before you take the derivative of each and then find the product of the derivatives. Questions? Excellent. Okay. Hi!
I saw the sign. I'm like, is it really close?
Oh, yeah, it's calculus.
Okay, sorry.
No, that's okay. I met her earlier today. She's really nice. I laughed an inappropriate amount, didn't I? It wasn't that funny. Okay. Has anybody seen the show New Girl? Because one of my tutoring students told me that I'm like, she thought that I was the main character in disguise for the first couple of times that she came to me. Like, this was just my side job. It's like, no, I am not Hollywood salary level. Unfortunately. So, okay. So, you want to do a harder one? Of course you do. So, yay! Okay, so differentiate y equals 1 over the cubic root of x squared plus x plus 1. Oh, it's really not that bad. Because that just equals x squared plus x plus 1 to the negative 1/3. So, y prime is the negative 1/3 times x squared plus x plus 1 to the negative 4/3 times the derivative of this function, which is just 2x plus 1, which gives us 2x plus 1 negative over 3 times the cubic root of x squared plus x plus 1 to the 4th. Not so bad. It's a beautiful function. There it is. Send it into the Louvre. And those French people wouldn't even dignify us with a response. Okay. So, any other questions about the chain rule? Okay. Another example, because it does get a little bit harder. Okay. But you guys can do it. Faith in you. Okay. Let me just make sure that the angle's okay. Yeah. Okay. So, g of t equals t minus 2 over 2t plus 1 to the 9th So, step 1. Right? But not done. Times the derivative of the inside, for which we need to use the quotient rule. Just sitting now because it's more convenient. Okay. So, distributing that nonsense. It's just 2t plus 1. It's actually, I feel really bad. I feel like I was disrespectful to the multiplicative identity right there. It's a very important thing. Okay. So then minus, and then we have 2 times t. And we have 2 times negative 2. So we're subtracting negative for that. And we get plus 4 over 2t plus 1 squared. But let us not forget that we also have 9 over t minus 2, or times t minus 2 over 2t plus 1 to the 8th, which equals, this becomes, oh, no more t's, 5. And let's just go ahead and multiply it times 9. There's no 9. We have t minus 2 to the 8th over 2t plus 1 to the 10th. Can you see okay over my bag? Is the takeout bag? Okay. Does that make sense? Because this would simplify to t minus 2 to the 8th over 2t plus 1 to the 8th. Then we have 2 more of those, so that becomes to the 10th. And that's the answer. Any additional questions about that? Excellent. Okay, sorry. let's do the next one. I'm just laughing because it looks scary, but it's really not. That jerk Isaac Newton coming up with all this crap in 2 years. Anyway. Okay. If f of x equals the sine of the cosine of the tangent of x. Did you say y? So then what is f prime of x? So, woot woot. Okay, the derivative of this is cosine, right? So it's not cosine of x, it's the cosine of tangent x. Okay. Times good. Okay. The derivative of the rest of it, right? So now we're up to cosine times the cosine, or of the cosine, of tangent x times, well, the derivative of cosine is negative sine of tangent x. And we still need to multiply that times the derivative of tangent x. Which equals, and this is why it's called the chain rule. See the chain? Chain, chain, chain. Okay, so we have the cosine of the tangent of x times, well, let's make that negative, sine of tangent x times secant squared x. Not so bad, right? I mean, there's just 1, 2, 3, 4, 5, 6, 7 trig functions in one. Did it make sense? Good. Do you think that when we ask questions about what they're doing and then they hear me laugh like that, do you think that they ask questions about what we could be doing in here? Because they haven't asked what class this is. So, like, evil cackle class? Kids, take your new elective. How to evilly cackle. Perfect. Thanks, Sam. Okay. So, yeah, let's go ahead and do it. You guys can handle it. Excuse me. So, y equals secant cubed x to the 1/2. So y prime is equal to 1/2 secant cubed x to the negative 1/2 times the derivative of secant cubed x, which is going to equal 1/2 secant cubed x to the negative 1/2 times, sorry, I have a suggestion. You want to girl? Okay. 3 secant squared x times, times the derivative of secant x, which equals 1/2 secant cubed x to the negative 1/2 times 3 secant squared x times secant x tangent x. Which equals 3 secant cubed x tangent x over 2 times the square root of secant cubed x. Oh, oops. I forgot to throw in Does this make sense why I had to add that? The 3x squared? Because we were cubing the secant function as a separate and composite function. So using the power rule on that is 3 times the argument squared. You want me to go over it again? Okay. Starting from up here. To avoid confusion, to do this part of the derivative. So just focusing on this part, we have u cubed, which is 3u squared, times secant x. Was I right? Hang on. Oh! I was right. Because I'm still going to get the same thing. I put the exponent in the wrong place versus the example. So what I just had was correct. I was just trying to make it match something without realizing I had made a mistake. Yay! So if you didn't, did you erase already what you had? Whew, okay. That was right. Because then we'll still get 1/2 secant cubed x to the negative 1/2. Just don't compare this to the book because it won't match. And then times 3 secant squared x times secant x times secant x tangent x. There you go. And then you just simplify that. Good? Okay, so does the chain rule make sense? Yeah. When you're doing these problems, I highly recommend that you, like for example, just to do what we just had, y equals the square root of secant cubed x. U equals secant x. F of u equals then u cubed. And then you would have g of f of u is the square root of u cubed. Make sense? Like break it down as soon as possible. Find out what your individual functions are, because the chain rule says you have to multiply all those derivatives together. But your derivatives of some of them, you might need to use the product rule, or you might need to use the quotient rule. So step by step, So y prime would be, you have the square, like the square root, the big one. So right here, you have u to the 3 halves. So it becomes 3 halves u to the 1 half. Does this make sense? And then you're just going to keep going. And then times 3u squared, because that's the derivative inside. And then plugging u cubed back in, or plugging u back in to secant x, then you would need to take the derivative of secant x as well. Okay? So every step of the way, every time you take a derivative, or every time you take a derivative of one of your composite functions, make sure that you indicate that you need to take the derivative of the other one too. So like 3 halves u to the 1 half times d dx or d du of u cubed. Because then you can plug secant x back in from here, and you'll get y prime equals 3 halves secant to the 1 half x, or my fault. And then you have times the derivative of secant cubed x. And then you can use substitution again right here to recognize that when you do the derivative of this one, you will also have to use the chain rule. So you had to use the chain rule here, and then you'll need to use it again. Does that make sense? Okay. Don't be afraid to use this notation as you go through. Don't try to derive everything at the same time with your next line. You will get lost. And just repeat to yourself over and over, chain rule! Chain rule! Because these are going to be some nasty looking functions that we're going to be working with this year. And you can't forget to take the derivative of one of those parts and then multiply it in, or you won't get anything close to the right answer. Okay. That sums up class. So, poor Sid. The homework is page whatever this is on. Sorry. 1 through 79 odd. And 87 and 89. And I've already started doing this homework. Yeah. I just burped quietly and I realized you guys didn't hear it, but Sid probably did. Okay, so that's it for class. Yay!